octopus with no legs.
Oh, I think I heard what you...
An octopus.
An octopusy. An octopusy.
An octopus with no
He's not going to be very tough. He's just going to stand on it.
He's just going to be a ball.
I only remember this because one time I was in baseball.
Oh, yeah!
No, I remember next he said it was going to be slightly inappropriate, so I was like, what's inappropriate?
That rhymes with octopus.
Anyways,
Okay, so let's find all this stuff. How do you find, and all of these will be fractions with a polynomial on the top and a polynomial on the bottom. Or they could be factored. How are you going to find the x-intercepts for this?
Plug in 0 for y.
Yes.
Plug 0 for y, as usual.
and so.
So 1 and negative 1.
I don't need to write that down, right? And really, what are you going to do once you plug in 0 for y?
Multiply both sides by that and you still get a 0.
Can we do a step ahead of schedule?
You're going to put the x minus 1 on the other side.
On the top.
Okay, what I was trying to go for is you don't need the bottom.
Because it's multiplied by 0.
You can't just...
Because if you multiply both sides by x minus 1, what happens?
It's going to be 0.
Yeah.
0 equals x plus 1. So all you care about is what makes the top 0. That's your x-intercepts.
Oh, okay. So
Because if I multiply both sides by x minus 1, to get rid of it off the bottom, times x minus 1, 0 times x minus 1 is just 0, and that's always going to happen.
Okay.
And
So the x-intercept is just what makes the top 0.
yes,
Okay.
So we're just going to be negative 1.
x is negative 1.
So there's only one x-intercept for this one.
So there's only one x-intercept for this one. There may be multiple.
So the x-intercepts will always come from the top.
Can you just explain how that works? Like, I see it, but I don't understand.
See what?
Just how... So you don't do anything with the bottom?
No, he did do stuff
I
with
multiplied
bottom.
both sides by x minus 1. X minus 1 times x plus 1 divided by x minus 1 is x plus 1.
Alright, but...
And then x minus 1 times 0 is 0.
Wait, can you do that? Because if you do that to the other side, like, you just get rid of it.
Yeah.
I thought in math you can't just get rid of things. It always has to be...
Well, you're multiplying by 0, so it's okay.
X minus 1.
If you multiply by 0, it does go, it's just 0. It goes away.
I'm stressing right now.
That's the only time, is when you multiply by 0. And since we plugged in 0 for the y, just to find the x-intercepts.
Apparently we have 3 days until our next test, so I'm kind of trying to figure stuff out.
Tester quiz.
Yeah.
3 days.
Friday, question mark?
Monday. Oh, it's Monday.
Tester quiz.
You're scaring us.
Sorry.
Next.
The test will be in about 7 more days.
But there's a quiz and there's...
Probably. Okay.
Okay, continue.
Would you like to graph 2 simultaneously?
No.
No.
Okay.
Yes.
What do you mean graph 2 simultaneously?
Like, I'm going to give you another one, and then we'll do the x-intercepts with that one, and then we'll move down the list, y-intercept. We're
Yeah,
going to
sure.
just go down the list for each one.
Yeah.
You might as
Why
well.
not?
Let's just finish this one.
Yeah.
X is negative 1. Okay.
Is the y whatever makes
And I'm
the
actually going to do it on a
bottom
different paper, though, that x equals negative 1. Here's my graph. That's all I know so far.
Vertical asymptotes.
Let's do y-intercepts. How do you find the y and plug in 0
zero?
for
Is it
x?
whatever makes the bottom 0?
Plug in 0 for x.
So negative 1.
0 plus 1 over 0 minus 1.
Negative 1.
Negative 1.
Stop.
Good. Got a couple key points there. Vertical asymptotes. Where are those going to happen?
1. That's it.
That's it. Yeah, vertical asymptotes, that's where the domain doesn't exist, right?
Yes.
Remember when we did domain? What is the domain of that?
Been a while.
X cannot.
Everything but 1. X cannot equal 1. Which means when you're at x equals 1, that's your vertical asymptote.
X equals 1 or negative 1?
1. So if I plug in 1 for x, what do you get for y?
0.
2. No!
Oh wait, undoable.
You can't divide by
If
0.
you did f of 1, you would get 1 plus 1 over 1 minus 1. That's 0. 2 divided by 0 cannot do it. That's where you're...
That's what I meant.
So-
Vertical asymptote is whatever makes the bottom...
Set the bottom equal to 0 and solve. Because they will get more complicated to where you cannot just do it in your head.
Alright, if there's...
Example.
Not yet.
I'll give them an example. I'm not gonna do it, but I'll just show you it.
So it would be x minus 1 equals 0.
Wait, can we graph this? Let's try to see.
Actually, these are all pretty easy. Oh.
So you just take that equals 0, and then you...
Yeah, you set the bottom equal to 0, factor it, and then there's gonna be 2.
Wait, we're putting at 2 or just 1?
We're gonna have that one.
Okay. Because you also had your pinky.
Well, those, it's all factored. So you gotta still, there's gonna be multiple vertical asymptotes, because when you set the bottom equal to 0, there's multiple different things that'll give you 0 on the bottom.
-3.
-3, -2, and -1. Those are your vertical asymptotes. This one you gotta factor it first, no big deal. This one will be 3. These, just whatever makes the bottom 0. That one you're gonna have to factor.
That's already figured out the factored one.
That's vertical asymptotes. Here is the crappiest part of this. The other asymptotes. Now I even need my notes for this.
Vertical. I mean, horizontal.
No,
Huh?
diagonal.
Wait, what? I heard a wait.
Yeah, never mind. I got it.
Vertical and slant.
Speak your mind. Speak now or forever hold your peace. Other asymptotes. There could be horizontals, and there could also be slanted ones.
Well, I was making
You mean diagonal?
Diagonals. Yeah.
Wait, for the...
Look, you were
not
trying to
slant,
speak
but for-
educationally.
They're actually literally called slant asymptotes.
Yeah, but they're diagonals.
I believe diagonal implies it has to go from one corner to the other corner. These could be any slope. If you look up the definition of diagonal, I think there's a reason it's called slope. Or slant. Jeez. Trying to get all wordy. What?
Good for the horizontal and vertical asymptotes, could you use just x asymptotes or y asymptotes, considering horizontal, I believe, is on the x-axis.
Not always. Horizontal could be anywhere.
Wait, what?
You can have a horizontal asymptote down here, you can have it up here, you can have it down here. you can have
Yeah, X.
Okay, then that could be like the y
it
axis.
on the x-axis.
Oh, X line. Oh, bad. Never mind.
They're horizontal, so they're parallel to
Yeah,
the
yeah, yeah.
x-axis, but they're not on the x-axis necessarily. Could be down here, it could be up here. And you could have slanted ones that are like this, or like this, or like this.
That
or
they
here.
don't have to go through the origin.
They don't have to go through the origin? No, could be anywhere. So how do you find them, you ask? Good question. That's not what you're gonna ask? What are you gonna ask?
Go asymptote, why'd you plug in 1?
Because that's what makes the bottom 0.
Oh, okay, so.
Set the bottom equal to 0. X minus 1 equals 0. Add 1. X equals 1.
And then that's how you find the
Well,
vertical?
you probably should have just given us the entire period for the test. We have 1 minute left.
Thanks. At 3 o'clock.
I don't think so.
Other asymptotes. Give you one of these.
We should have put one of these
We could.
We could have a test on a lot of things tomorrow.
Yeah, probably could.
It's gonna talk us through
Or
it,
you
or
can
he's
just like
gonna leave it
continue
here.
this after school and then put it on YouTube.
Rules. There's 3 rules for these. You remember these? Do you like actually remember them?
No, I don't know if I remember.
And we'll learn about it tomorrow.
One of them has to do with the powers.
Copy dot flip.
Go.
What do you call a snake? It's exactly 3.1415926 feet long.
A python.
A python.
That's a freaking dead
I love it. That's awesome.
Heard that
I will
earlier.
tell them
Stop
what
math dad jokes
to do. My
2017.
dad,
Stop that
he's
joke.
gonna laugh so hard.
Alright, here we go. We were graphing this sucker, and we found, here's the things, here's how you're going to graph all of these. You're going to find x-intercepts, you're going to find your y-intercept, you're going to find vertical asymptotes, you're going to find other asymptotes, and then there's going to be a number 5 down here.
Okay, what are the rules?
There's like 5 steps to graphing a rational function. We talked about x-intercepts, y-intercepts, vertical asymptotes yesterday. The other asymptote rules. Okay. Trying to figure out how in depth I want to go there. Let's just write basic forms of the rules.
Lingman's terms, please.
And I can tell you why they work if you want to know. If the degree, you know what degree means?
The
thing you
get when you graduate.
Power
The largest
I saw
power.
that from over there.
of the denominator is greater than the degree of the numerator.
Okay.
Then y equals 0 is your horizontal asymptote.
So the x-axis.
Yes.
And y equals 0?
Yep. That's the x-axis. The x-axis is a horizontal asymptote if the degree on bottom is bigger than the degree on top.
So like x squared on the bottom and just x on top.
What do you
Yes,
mean
sir.
by degree again?
Degree is the power, the highest power,
So like x to the third is the third degree?
if it's the highest one.
Okay. Okay.
Assuming you write them all in order in standard form, then it'll just be the front power.
Okay.
And if it's not written in standard, do you want us to change it?
I would change it, yes, definitely, so that you don't miss one. Is greater than the degree of the numerator. Y equals 0 is your horizontal asymptote.
So whatever makes.
So if the bottom has the highest degree than the one on top, then the y-axis will be a horizontal asymptote.
Yep. And here's why that works. Just because, you know.
Because Henry used to know.
Yes, please.
You can't just accept things at face value. You have to
Why
see
does
it.
that work?
Well,
Because it's not just some rule that some dude made up.
Well,
That's not how this works.
That's how most math
That's how explaining
Yeah,
math
isn't it just like
Some
some
dude was like,
guy
hey,
that was like, hey,
Hey,
this
I need to
works.
solve this somehow.
So let's use you're just x over x squared. And there could be a bunch of other stuff. Or like x plus 2 over x plus 3, blah, blah, blah. This stuff doesn't matter. Because horizontal and slant asymptotes, they exist because it's a number that y approaches as x gets really, really big or really, really small.
Okay.
So, like for this one, as x approaches infinity, the top, the numerator, is going to be like infinity, right? Infinity plus 2. The denominator is going to be infinity squared. But the idea is this is going to get really, really big, but this is going to get really, really big a lot faster, isn't it?
Okay.
Yeah.
Okay.
And what's a big number divided by a really, really, really big number?
Really close to
Little
0.
number.
It's going to get really close to 0, isn't it?
Yes.
So if I just did like x over x squared and we actually plugged in some numbers, like if you
3
plugged
and 2.
in,
500.
if you plugged in 10, it'd be 10 over 100
Or
or
110.
1/10. If you plugged in 1,000, that's 1,000 over 1,000,000.
Or hey,
000, a millionth, and to get rid of 3 zeros, 1/1000th. It got smaller, didn't it?
Yeah.
Yeah.
That's going to continue to happen because you're squaring the bottom one, so that's growing at a lot faster rate than the top one.
so it'll
Okay.
just continue to get
So it's just
smaller,
going to continue to get
smaller.
smaller and smaller and smaller and smaller because that one's getting bigger faster.
I have a question.
Same thing if you go negative direction. Negative directions is the same idea. This one's going to get bigger real fast. Huh.
What is the point of horizontal asymptotes if they're just going to get crossed anyway?
Well, they can get crossed in the middle because the reason they exist is because of the end behavior.
Okay.
So it's just for end behavior. Like as x gets really, really big or as x gets really, really, really small.
Okay.
That's your first one. That one's easy. Next one, if the degree of the denominator, can I abbreviate?
Yeah.
Degree of denominator equals degree of
So if they're the same, you're saying?
so they're the same.
Like x over x.
Yeah.
Well, x
squared over x squared.
There has to be other stuff because we just had x over
Well,
x.
yeah,
That's
but-
one. But yeah, the highest degree on the top is the same as the highest degree on the bottom. Then, let's see how we're going to write this. It's a lot of words. You take the leading coefficient of the numerator divided by the leading coefficient of the denominator.
Okay,
Oh.
so the thing
So
in
if
front
it's
on the
2x
top
squared
divided by the thing on the bottom.
Yeah.
So the leading, the coefficients.
Yeah,
So
2x
2x squared divided by 3x squared.
So let's say you had,
3
so how are we going to write that? Lead coefficient
The front thing.
over lead coefficient.
Yeah, so you
They
just use the whole.
You just get rid of the other crap. So if it was like x squared plus 3x minus 4 over 2x squared minus 6x plus 2,
Yeah.
your asymptote would be y equals 1/2. So that's where you get your slanted ones.
And how slanted is it? What determines the slope of
Is the
the
numerator one on top?
These leading coefficients.
And so it starts.
So y equals 1/2, so it'd be, how would you,
So it's gonna be over 2 up 1 on the
So like
side.
on your graph, it would just be start at 0, up 1 over 2.
oh, okay.
And that's,
That's the vertical axis.
that's your, it's called the slant
So it's
asymptote.
y equals 1/2 x for the, like, if you,
That's sort
So
of
it's like you're getting
Oh
another
shoot,
one.
I am not, oh my,
1 plus 1 and 1.
It's just that 1/2, isn't it?
yeah,
It's not a slant asymptote.
that's not a slant asymptote, freaking A, that's just y equals 1/2.
Yeah, I was gonna say.
Holy smokes, that's y equals 1/2.
disregard the slant.
There's no
asymptote.
x there, just, yeah. I'm getting a little ahead of, there is a slant, that's the next one.
What?
It's not a slant.
It's
one.
not a
It's just-
slant,
Where is that?
that one isn't, because it's just y equals 1/2.
yeah, I
Y
was
equals 1/2 is a
I was gonna
horizontal
say.
line at y equals 1/2.
Yeah, at 1/2.
Hey, we all make mistakes.
Everyone makes mistakes.
Everyone has those days.
I know that sounds way too well.
And not a little much.
Is everyone thoroughly
That's
confused
something
now?
just seared into my brain. No joke.
no,
Seared in my brain.
Do you want to know why on that one, or we just move on?
I think
No,
we're
let's
good.
move on.
I think we're good.
It's kind of.
So yeah, and so whatever that fraction is, y will just equal that. So if you had, let's do one more just to make sure. So if you had like 6x squared plus 3x minus 4 over 3x squared minus 2x plus 17.
so it'd be 2 over 1, so it'd be 2.
Yep, your horizontal asymptote would be up at 2, y equals 2.
Why is that?
As it goes out to the end. It can cross these, but as it gets out towards the end, it's always going to go. Okay?
Why?
And then the last situation, degree on the bottom is bigger, they're equal. What's next?
Degree of the bottom is smaller.
Smaller. Degree of denominator is less than degree of numerator. This is where you get your slants.
So the one on top is bigger than the one on bottom.
Yeah.
Yeah.
We could have wrote them all flipped, but I just stuck with denominator first. If this happens, what's this book say? I usually do long division. I don't know what this says to do.
Wait, so shouldn't this be,
Is that the book from Big Ben that they
Yeah.
use for their pre-calculus class?
This case, well, this is all confusing. I do long division.
Just divide what's on the top by what's on the bottom.
This doesn't even make sense. Should have read this before class.
isn't that why you have a first period off?
It's okay,
First period?
we can cut this part out of the video.
Yeah, when you have 5 different freaking classes, you have to first word. Sometimes you guys get the short end of the stick on that.
I saw
It's okay, we figure it out together.
Yeah.
Leading coefficient over
The numerators.
the top one.
Anyway, here's what you do. Long division.
What?
Do long division.
Oh, is this one you were thinking of?
Yeah, I was trying to read what they said, and I don't even know. I do long division, and then you ignore the remainder, and the other part is the equation of your asymptote.
Oh, okay. Okay. So it would be y equals whatever you get for the answer.
So let's say,
And if it doesn't have that, you don't have the slight asymptote?
If the degree of the denominator is less than the degree of the numerator, there will be one.
So like X squared.
So
There
like
will be a
2
remainder.
x to the third